So what we're going to do is first show you how to do ray diagrams for concave or converging mirrors. So the first rule is that any ray that is shot through the focal point, which is labeled F over here, will reflect parallel to the principal axis, which acts like the normal line when it comes to curved mirrors. So let's say I draw my incident ray through the focal point, and I'll kind of adjust it over here. Remember that the rays are generated by the object itself. Then it's going to reflect back, and we'll draw the reflection in green, parallel to the principal axis. What we mean by that is that it'll also be a relatively horizontal line. Now you would draw this with a ruler so that it actually looks completely parallel. But this is the general rule. So if you shoot the line through the focal point, or the point in the principal axis that is labeled F, which is in between the center of curvature and the actual mirror, then it reflects back. Now, rule 2 states that let's say I have an incident ray that is parallel to the principal axis. So unlike the previous one where we went through the focal point, if I shoot an incident ray from the object to the mirror that is parallel to the principal axis, then it will reflect through the focal point. So that's going to be the opposite of rule 1. Again, you would draw this through with a ruler so that both lines should be straight, but you can see the reflected ray in green is through the focal point. Now, to create an actual image, you need at least 2 incident rays so that they can intersect on the other side. So, by combining both rules, we actually get a point of intersection. And that point of intersection, which I've labeled in purple here, is where the image is formed. Since both rays come from the top of the object, the point of the intersection must also represent the top of the object. So the arrowhead that is the top of the object is going to be drawn at the point of intersection, and that's where the image is going to be created. So what I would see when I draw that is I would see that the arrowhead is now upside down or inverted. And so the general rule of thumb here is once you have your intersecting lines of the reflected rays specifically, so what's written in green here, that's going to tell you whether the image is inverted or if it's upright or erect. And we really let the intersection do all the talking. Now, although the image is inverted, it is still considered a real image. And that's because the image, as you can see from the diagram, it's in front of the concave mirror. It's not in behind. And so you would actually literally be able to see it in front of you. And so from the intersecting lines, we can tell that the image is inverted, but it is a real image, as opposed to upright or virtual. So then we come up with a rule of thumb where we say that for every image created, you will need to describe the 3 characteristics. The first characteristic is the magnification of the object. And that's whether the object will look smaller or larger, or in some cases, the same size. The second characteristic we look for is the attitude of the image. And we're not talking about whether it has a poor attitude or a good attitude. We're talking simply about whether the image is upright, or a synonym for that is erect, or if it's inverted. And then the third thing that we look at is the image type. So is it real and in front of the mirror, or is it virtual and behind the mirror? And what you'll notice is that each lens, or I should say mirror, tends to form a predictable image type of whether it's real or virtual. So if the intersecting points are behind the mirror, then it's going to be a virtual image. The third rule is that any incident ray sent through the center of curvature, or the C, that we can see in green will reflect back through the center of curvature. And this is actually a pretty inefficient way to send an incident ray from the object to the mirror, but it is a possibility. So let's say in yellow, I shoot it through the center of curvature. Then the reflected ray would just go back the exact way that it came in green. Okay? So it would look like, in ray diagrams, a really bold line. Okay? So you have the incident ray in yellow that is covered by the reflected ray in green that reflected right back the way it came. So here's a mirror type where the lens is curved outwards as opposed to inwards. Now, for the diverging mirrors or convex mirrors, and you can call them either one, they're going to have the same set of rules that the converging mirrors have, except that the focal point and center of curvature are going to be in behind the mirror. And so one thing that you could always say right off the bat is that convex mirrors are always going to have a virtual image, and that often the images are going to be shrunk or smaller. In other words, diminished. So, much like in converging mirrors, if an incident ray is shot parallel to the principal axis, then it will reflect through the focal point. Except what we're going to do is, because the focal point is in behind the mirror, we're going to extend the reflection lines behind the mirror as opposed to reflecting them in front like the converging mirrors. So in this case, the reflected line, which at one brief moment is in front of the mirror, is extended in behind or angled toward the focal point, which is behind the mirror. And again, remember that we already know that your diverging mirrors are going to produce an image in behind. Now, the second rule is, again, just like the one of the three previous rules. If an incident ray is shot through the center of curvature, it will reflect back the way it came. So if I have an incident ray in green that is going to be shot through or towards the center of curvature, and I'm using the ruler here to extend it, in purple, it will reflect back the exact way it came. Now, we are going to also draw the reflection lines in behind the mirror towards the actual center of curvature. Now, what you're going to notice, right, is that the two lines, because remember we need two lines in order to create an actual image, the two incident rays are going to intersect just right before the focal point. Given that the incident rays originate from the top of the object, where they intersect in behind the mirror is also going to be the top of the object. So we will draw it starting at the top of the arrowhead and then all the way to the principal axis. Now, like we did in the previous questions, we're going to describe some image characteristics. So we can see that it is clearly upright. It hasn't been inverted at all. We can also see that the image appears to have been shrunk. Okay, so, and that's based on the intersecting lines. So remember, let the intersection lines guide how your image looks like. So it's going to be smaller or diminished, as other textbooks would say. And of course, we're comparing this to the original size of the object. So the image in gray is significantly smaller than the object in purple. Now, another thing that we can say is that it's a virtual image because it is clearly formed in behind the mirror. And so often you're going to have to describe these three major characteristics: the size, location or nature of the image if it's upright or if it's inverted.